Greetings to you all, and a very warm welcome to our pre-COP webinar where we focus on climate solutions. A special warm welcome to our incredible speakers who will share with us their amazing work that they do in their respective organizations. This is one of many pre-COP webinars that Nuclear for Climate is organizing. My name is Prince Mtombeni. I am a nuclear communication specialist from South Africa. I'm also a founder of Africa for Nuclear. I am also a member of Nuclear for Climate Program Committee. The format for today's webinar is TED Talk-like. Each speaker will give a presentation within the allocated time. We will unfortunately not have the Q&A session, question and answer session. So everyone who's here, before we start with the first session, I'd like to remind you to make sure that your microphones and your videos stay muted and are switched off all the time. Only speakers are allowed to have their microphones on and the videos on, but only when they are speaking. Welcome once again. I'd like to give you a short presentation about COP as well as the Nuclear for Climate. Basically, I just want to give a brief background of Nuclear for Climate as well as COP. What is Nuclear for Climate is a global grassroots initiative of 150 associations and NGOs, among others, many United Nations observers. The goal for Nuclear for Climate is educating policymakers and public about nuclear technologies in service of climate mitigation and adaptation. It was established in 2015. At COP26, Nuclear for Climate had 90 delegates, and we also had a pavilion. We also organized various side events, including the flash mob. As you can see on the pictures, we really had fun. So I'd like to briefly talk about COP. What exactly is COP? COP is the COP stands for Conference of the Parties. It is a series of United Nations Climate Change Conference, which have been running since 1995. The goal of these conferences is to review progress made by members of the United Nations Framework Convention on Climate Change, UNFCCC, to limit climate change. COP is the main decision-making body of the UNFCCC. It includes representatives of all countries, including presidents. There are signatories of the party. There are signatories to the UNFCCC. It assesses the effects of measures introduced by the parties to limit climate change against the overall goal of the United Nations FCCC. COP meetings primarily revolve around negotiations and debates. The aim is to review progress towards overall goal of the UNFCCC to limit climate change. The convention has 197 nation parties as of 2021. COP26 was held in Glasgow last year, and COP27 will be held in Egypt at Sharm el-Sheikh from the 7th until the 18th of November. By 2012, global emissions were reported to have doubled from those of 1990. So Paris Agreement was developed in 2015 and it entered into force in 2016. The main aim of this agreement was to, number one, limit the global warming to below 1.5 degrees Celsius, limited to a maximum increase of 2 degrees Celsius above industrial levels. It was also to strengthen the ability to adapt to climate change and build resilience. Also to align financial flows towards low greenhouse gas emissions technologies and climate resilient development. And lastly, the aim was to reach a climate neutral world by 2050. As you know, net zero needs nuclear. A campaign that we had last year, it was to also mention that it was also to cover this goal. In Glasgow last year, the negotiations reaffirming the goals established in the Paris Agreement. were the following: it was unclear on how much and how quickly each nation should cut its emissions. Also, how the phasing down of fossil fuel subsidies. And lastly, according to the climate action tracker, the current policies put to the world on the path to a global warming of 2.7 degrees Celsius. And why do we think COP is special? Because COP27 is special because it is happening in Africa. And the theme is Together for Implementation. African countries bear the brunt of the most severe impact of climate change. Will be the front and center of the discussions. What the upcoming COP27 aims to achieve is moving out from pledges to implementation. As Greta Thunberg would say, the blah, blah, blah part should be over, and people should start talking about the implementation processes. And also, we aim to achieve the adaptation and adjusting to current and future climate change impacts. We also aim to reach more finance contribution by developed countries within the space of 2020 and 2025. And lastly, we aim to achieve the loss and damage, and as witnessed by developing countries. We aim to address the loss and damage that has been witnessed by the developing countries. So I think this is just the end of my brief background about Nuclear for Climate and COP. And now we are moving to speakers, and I'd like to introduce to you the first speaker, which is Ahan Evrenstal, who is a communications consultant at the International Atomic Energy Agency. Ahan will talk to us about the climate smart agriculture, water resources management, and ocean. So over to you, Ahan. I'll stop sharing.
Thank you so much, Princess. After your introduction, I will start. Everybody can see me, right?
Yes, we can see you and we can hear you.
Okay, very good. I will start with showing something, because you were talking about emissions and we all talk about emissions. What are we talking about? I don't know if you can see this vial in my hand, but this is the global standard of CO2 that is produced in one of the IAEA laboratories that we send to laboratories across the world to calibrate their precise machinery for measuring the CO2 emissions. So if you can look closer, it's the global standard of CO2. Now, this vial costs a few €100 to produce and to ship to hundreds of laboratories across the world. So our colleagues have come up with something much easier to carry, much easier to produce. It's basically a copper, and in between my fingers here is the same CO2 reference that we now will start sending to laboratories across the world. This item costs €20. So we're talking about efficiencies and CO2. Let's see what we're talking about. Now, I will share with you a few ideas on how the IAEA helps countries in mitigation. So, the IAEA is known as the nuclear watchdog, is known a lot in nuclear power discussions. Last year for Glasgow COP26, we produced 2 documents. One was specifically about reaching the net zero, and the other one is the very new one that we will produce now for COP27, the one on the right side, about mitigation, adaptation, monitoring. I think the next speakers will talk more about energy, and that's also not my current area, so I will not talk about energy. We all know it's the second low carbon electricity in the world. We know it's part of the solution to address. What people mostly do not know is how nuclear science and technology actually immensely helps countries in managing the climate change. So I will talk about climate smart agriculture, water resources, and ocean. How do we do? Just the background, the reference material that I have shown to you, the CO2, is produced in one of our 12 unique laboratories. The IAEA within the UN system runs these 12 laboratories in Vienna, outside Vienna, in Austria, in Seibersdorf, and in Monaco, and they are clustered into certain work areas. The research and development that we do there is applied directly in the member states. So let me start with the first example on food and agriculture. Agriculture, most people would not know, is actually both a victim of the climate change and a culprit of the climate change. It is the second largest source of greenhouse gas emissions. But of course, the changing climate also has its impact on the agricultural products that we do. So what we do is we can measure the amount of fertilizer the plants take up and provide the farmers back in the countries with optimal amount to use what they should be using, which actually would help cut the emissions from agriculture by half. This is a huge service. Now, we talk about agriculture being a culprit, so to say, in that sense. It also consumes 70% of the global freshwater use. So it leads in the long run to desertification, it leads to soil degradation, but with the precision of nuclear technologies, we can measure the optimal amount of water that is needed by a plant, that this soil needs there, not more, not less, and that will help the farmers, that will help the countries to use the optimal amount of water. Because soil degradation is an amazing problem that we have. If we continue with the way we have been doing agriculture, with business as usual, soils will be eroded up to 100 times faster than the natural processes can replenish them. So we need the precision of nuclear technology in telling the countries, the farmers, what do they need to, how much do they need to give, both in terms of water and in fertilizer, so that they get the best amount. When I say the best amount, here is a bag of rice from Laos. Through better soil and nutrient management practices, through the precision of nuclear technologies, the rice yields in Laos have risen by 60% by bringing up new varieties of rice that can give more yield. Here's another example from Pakistan. Cotton makes about 9% of Pakistan's gross domestic product and accounts for 60% of its exports. But climate change is a big burden on Pakistan cotton exports. So together with the Food and Agriculture Organization of the FAO, a new variety of cotton that we have produced jointly with Pakistani experts now make up 40% of all cotton produced in Pakistan. So this is a huge amount, because this cotton is climate resilient. So it needs less water and it grows in harsh conditions. You remember I said agriculture is both a victim and a culprit. On the victim side, climate change also causes new diseases that did not exist in a particular area before. So banana and coffee plantations across the world are under threat by new fungal diseases that did not exist in those areas. Again, like the cotton example I have shown, we're helping countries develop new varieties of coffee, banana, and several other sorghum, wheat, barley that either are resistant to certain diseases, or that need less water, or that give more yield. So I will continue now with another very interesting example. What you see here is the mosquito, the Anopheles arabiensis, because climate change also contributes to the spread of insects. They go cross-border, obviously, and they breed in areas where they were not there before. And the IAEA and the Food and Agriculture Organization, we are using a technique called the sterile insect technique. And with this, we help countries manage the invasive species of mosquito, fruit fly, tsetse fly, and others. So from Brazil to Spain, Tanzania to Mexico, the sterile insect technique has helped fight insects that harm both human health and economies. Now, let me move on to water. Managing water is like managing your money. Basically, you need to know how much you have now, how much you will have tomorrow, how much you can take out, and what are the changes, what can happen. Miscalculations of water can have severe consequences for masses. So we use the isotopes at the atomic level to reveal the age of water. Now, why is that relevant? Why would the age of water tell me? Here you see there is a water that is aged about 100 years, which means it is replenished relatively quickly. There is another one for 40,000 years, and here is one that has not been replenished for the 1 million years. So with the isotopic techniques, we help countries find out answers to basically 3-4 key questions. Where is the water? Where do I have it? How much is there? How good it is? Is it quality water for me? And based on these calculations, then as a country, I can calculate my urban planning. I can calculate how long would it last for me in that particular area. How do we do that? We have been doing that together with the World Meteorological Organization under a database for the last 60 years called the Global Network of Isotopes in Precipitation, GNIP or GNIP. We have over 1,100 stations in more than 90 countries. So we collect precipitation samples from countries, and these give us the projections, how it has been doing and where it might go. These are very precise measures, and they give us data on the water's age, origin, and movement. Movement is very, very important. That basically is a key feed into policy making. We're about to expand this concept of precipitation to new networks covering rivers and lakes as well. Similarly, under the Sahel region, we're working with 13 countries, because under those 13 countries in Northern Africa, in Central and Northern Africa, the groundwater resources stretch over 13 countries. The water under the ground does not know the borders up on the surface. Is there enough drinking water in the Sahel? How long would it last? This is a very, very important. So we have an atlas of water, for example, in the Sahel. Very recently, we have launched a 5-year research project on understanding sudden heavy rainfall events that we call convective rain events. What are these? These are sudden outbursts, sudden bursts of rain where a significant portion of the annual rainfall can occur within a few hours. How would that affect? Because the earth does not absorb that much, so it does not really seep into groundwater. So understanding such movements are key to planning our future. Now, from groundwater and earth water, I will move on to the ocean, which is both a victim of and a savior of the global emissions. Victim because the ocean absorbs 1/4 of all CO2 emissions, anthropogenic, human-made CO2 emissions. And what does that do? That basically makes it more acidic. So the ocean acidification has a huge implication on the coral reefs, on the marine organisms living around there, because the coral reefs supply food to millions of people. They act as storm barriers, and they're a huge source for both fishing and tourism revenue. So again, the nuclear and isotopic techniques are key in understanding how ocean acidification interacts. But I said the ocean is also a savior. It can help us. Actually, it does help us already because of the concept of blue carbon. Blue carbon is the organically absorbed carbon. Seagrass meadows, mangrove forests, tidal marshes, absorb and store the carbon much faster than any other ecosystem, such as forests. So we have several blue carbon projects in continents, in various countries, because it is one of the most important components of nature-based solutions to offset the negative impacts of climate change. And here I will stop. I hope I gave you a good tour of water, climate smart agriculture, and the ocean. And more on our science you will find in our upcoming document or on our website. Thank you.
Thank you so much, Ayhan. We appreciate your presentation. I wasn't aware that the agricultural industry is the largest polluter of emissions. Wow, thank you so much. And second largest, yes. And yet we focus on only one industry, which is energy. But thank you for that. I hope everyone like me learned something today.
Thank you.
I'm going to reshare my screen to introduce the second speaker. His name is Mike Crawford. He is a business development manager from Rolls-Royce. His topic today is SMRs on hydrogen production, heating, building, decarbonization, aviation, and metal industry. Mike, over to you.
Thank you, Princess. So firstly, just a quick apology. I'm suffering from COVID at the minute. So if I burst into a coughing fit, and just the general lackluster nature of my presentation and
no problems.
So yeah, quite a wide-ranging presentation from me, purely because it focuses on the thing that we do talk about a lot, energy, and because it shows how no matter what sector we're talking, we go back to energy at the end. So I'm from Rolls-Royce SMR, which is a slight offshoot of the Rolls-Royce business that was launched formally last year. If anyone wants to contact me after, because it's quite a short presentation, my email address will be on at the end. So Rolls-Royce historically has been around for over 100 years and has been active in the power market, so providing complex power solutions. Through the last decade, the company has realized very much that it needs to, if it wants to survive into the long term, it needs to transition to be part of the solution rather than part of the problem. Because you look at the mainstays of our business, historically, we've got jet engines, diesel generators for power systems, so that's shipping industry and backup systems, things like that. And then the defense industry, which again is lots of jets and diesel generators. So really, not a good look for the energy transition. So a lot of effort now has been put into how we turn that around and how we can not only decarbonize our operations and the products that we have, but the operations of everyone else. And that's where the Rolls-Royce small modular reactor business came from. It's been going for quite a few years, but formally established as an entity at the end of last year. So the beauty of a company like Rolls-Royce and having fingers in so many pies, being active in the whole energy ecosystem, you can see that it's a systems of systems approach. The energy ecosystem is so complicated. There are so many ways you can do the wrong thing and not really deliver value add. So understanding what all the facets of that are and what the challenges are, and then moving into the sort of technological solutions for those, how do they all fit together? If you're developing a solution that needs a specific fuel and the rest of industry moves in a different direction and that fuel's not available, and you've just wasted all that effort. So working out, in a systems of systems approach, how do we make all this thing fit together and make sure all of the effort, is in the right direction, because we really can't afford to be pulling in different directions. So the focus of sort of this whole meeting is around the solutions, and the solutions are out there. Technologically, there are a variety of solutions, whatever the sector. We know how to make synthetic aviation fuel. We know how to make green ammonia for fertilizers and to decarbonize agriculture. The problem is that to do any of these things, it all goes back to needing vast amounts of clean, zero carbon energy, essentially. And that ultimately is going to be the real driver to enable all of the industries to decarbonize. And so for me, I'm quite passionate about the work that I do with Rolls-Royce SMR, because I quite firmly believe that nuclear is not only central to a lot of this discussion, but actually essential if we're going to really be able to decarbonize in any at all, but certainly in any meaningful time frame. And so we spent a lot of effort trying to understand where nuclear power or new nuclear power can fit in this sort of decarbonisation effort. Because often people think about, power stations, they provide electricity to the grid and that's the end of the story. But one of the huge benefits of nuclear is the thermal power that it produces. And so if you map, as you can see here, sort of a wider range of use cases, you start to see very much that thermal energy, is not just something that we can think about later. It's critical. If we're going to decarbonize all of our fossil fuel feedstocks into the chemical industries, into the fertilizer industries, produce sustainable fuels. If we're going to provide potable water, drinkable water to most of the world, historically we thought markets like that were limited to the Middle East, but actually, as we've seen this summer, that could be important all around the world, really. So huge demand there for either constant power that is uninterruptible. Certain industries cannot turn off, data centers cannot turn off and rely on wind turbines to decarbonize because they need to be operating all the time, 24/7. So why should we go for nuclear? For me, it's quite clear. I've studied this quite a lot. Nuclear technology is a sustainable choice, and many people don't know some of the facts around that. There's often a belief that nuclear has benefits. Yes, it provides constant energy, but actually, it emits loads of carbon. It's nowhere near as good as solar and wind. But actually, depending on what you're trying to solve for, if you're trying to emit the least CO2 in the time we've got left, then nuclear comes out scores pretty well, even against things like solar and wind. If you're trying to minimize the amount of precious materials that we need to use, then because it's so power dense, we can do that. Land use, we're using land at an insane rate across the world, and so being able to protect those natural ecosystems and enable them to recover, again, critically important. So I won't linger on this, but lots of reasons why nuclear represents a sustainable choice, if not the most sustainable choice. And so we built the SMR program on 4 key value propositions, because nuclear has had some failings in the past. It's often been marked as too expensive and too slow, and so we need to fix those if we were to have a business that would not only could get going, but then could sustain itself through this energy transition. So critically, it had to be low cost. It had to be a competitive cost. If it was too expensive, it didn't matter how good a solution it was. It needs to be low cost. It needs to be deliverable, and we need to be able to get this thing moving quickly and deployed reliably. So we can't afford to be going over time and over budget, because again, the climate change will not wait for anyone. This is important stuff. We need to make it investable. We can't afford to wait for governments to act. That time has passed. We need to leverage the existing financial institutions and the money that is already out there. We need to bring that into play and really enable industry to invest in nuclear and really get this snowball moving, because we don't have the time to wait. And then on the same note, the solution that we come up with had to be global and scalable. The problem is huge. If anyone fails to decarbonize, we all fail. And so having that sort of equitable solution that not only we can enable anyone to have, but we can roll out at pace globally. So we went with something that's a factory produced product, essentially. So we can really, once we get going, start building these things rapidly and really make a dent in the challenge ahead of us. And there's got 2 quick examples here as to how the solutions all map back to a source of clean energy. So this one's very Rolls-Royce focused, so apologies for that. But it's a look at the aerospace industry, and we know what the solutions are today. Really, if we're talking about short-haul flight, we can use batteries. Rolls-Royce has broken the world speed record for electric flight, using a battery plane. It's not going to get you across the Atlantic, but for domestic flights, it's absolutely an option, and the technology is coming on in leaps and bounds. It's something that we're investing in as a company. How are you going to charge all those planes? That goes back to then a source of electricity that wasn't there before, because before you were digging it out the ground. So you've added demand onto the network. moving a little bit further in terms of distance, hydrogen could absolutely play an option. Many of the big airliners are looking into it. We know that won't get you long haul. So we'll get you a little bit further. You get a few advantages in terms of energy density. In order to make that hydrogen, guess what? You need a huge amounts of power, absolutely enormous amounts of power, and the numbers are truly quite scary once you see them laid out in front of you. And obviously that's going to cost you a little bit more because you've then bought extra equipment. You've got an extra step where you lose bits in terms of inefficiencies of producing that hydrogen rather than using it directly. Then for long haul, there is a solution to decarbonize, but it involves creating our own synthetic aviation fuel, because ultimately for that sort of real long distance flight, there is no way of beating the energy density of hydrocarbons. So if we want to decarbonize, then we have to make that in a sustainable way. It can be done. You start by making hydrogen, which needs lots of energy. You then also get carbon, which you can do if you've got a good source of carbon nearby. That's an option, and it's a good one. Alternatively, you can capture carbon from the air, which is something arguably we should be looking to do anyway. Now, the only problem is that needs even more amounts of energy. So you start to see that when you do this and then you combine them in sort of the Fischer-Tropsch process to make these fuels, the energy requirements just escalate out of all proportions. And so you really need a strong backbone there of clean energy that's going to hold up these systems in the future. So hopefully that's an interesting perspective, and I'll go through another example based on the same principle. So this is looking at the provision of thermal energy targeted at industry, heavy industry. So industries like the metal manufacturing industry, cement industry, glass industry, they're facing a real existential crisis, certainly at the minute with energy prices as they are. But they know they need to transition away from burning methane to produce the heat to undertake all of the chemical processes that they need to produce their products. And we need them to keep producing their products. We're going to need steel in the future. That's a given. We can't stop producing that. And indeed, many of the other solutions to the energy crisis are going to need that source of iron and steel. So we need to have solutions for them. So in a similar way, you can step through this process. Nuclear provides thermal energy, which is great because if you use that directly, you get huge efficiency savings in terms of the nuclear plant, because you don't have to convert that steam, that thermal energy, into electricity, where thermodynamics is a very cruel mistress, and you lose kind of 60% of the energy that you generate from those atoms. 60% of it is just lost as heat and ultimately goes into the the final heat sinks of the air or the sea or the rivers. And so if we can cut that out and use the energy directly, then that's great. We achieve really high efficiencies and even lower costs as a result. The catch there is you can only go so high with the temperature. So you can get to 300 degrees. That's great for some stuff. It's great for a few chemical processes, district heating, that sort of thing. But for the real energy intensive industry, you need to get further up there. So you can put the thermal energy, the steam, through those turbines, generate green electricity. That's almost the base way of thinking about nuclear reactors. They output electricity. So you can do that. You can then convert that electricity directly into heat. So there's a variety of technologies that exist, depending on what you're trying to do. But yeah, there are lots of people looking at transition to electricity because, again, it's going to be probably one of your most cost-effective options to get up there in the high temperature range. However, it's not always the best solution. So if you think about forges for making metals, they have, some of them have existed for over 200 years. They've got a huge amount of expertise in terms of the methods and the processes that they use, let alone the infrastructure. To completely replace that with a completely different method of heating things, it's really, really painful, and that pain equates to lots and lots of money. So if you can get a more like-for-like replacement, so burning hydrogen is an option because it gets you to quite high temperature and equivalent to burning methane, then that's something that will be very, very attractive to a lot of those industries. And indeed, they're looking at all of these. So just like in the last analogy, if you want hydrogen to burn, you have to make it. And so you have to start by getting that energy, splitting the atom, turning it into electrical energy where you lose in efficiency, and then making hydrogen, you lose more efficiency, burning the hydrogen, not too bad in terms of loss of efficiency, but nonetheless, hydrogen is notorious for sort of leaking and things like that. So every step along the way, you sort of lose a little bit from that only adds to what you need to put in at the start. And don't forget, again, none of this stuff is part of the energy demand of today. We dig this out the ground and it comes for free. So yeah, hopefully that gives everyone a good understanding of where nuclear can play in the sort of energy system of tomorrow, and the value proposition there are on the page. Low carbon power, energy security. This is very much not just in terms of having the long-term operation of a nuclear power plant, but critically, it will operate reliably, so you're going to get that energy when you need it. It's affordable thanks to the innovations that we're putting in terms of how we build this thing in a modular approach, utilizing factories, things that we've spent decades doing in the aerospace industry. The height of competition, a very competitive environment, you eke out all of the savings you can to make these things as affordable as they can be. The fact that we can fly to the United States from the UK for a few £100 is incredible, and is due to that competition and driving down the cost. The ability to provide thermal power, which many other low carbon power sources cannot do, and it is something that we critically will need, especially as we start to take away the existing thermal sources in fossil power infrastructure. And then the ability to put them wherever we need that power, which to saving the total system costs in terms of transmission and the total infrastructure of the grid, that's really important. Right, I've run out of time, so I'll just linger on that for a few seconds. If anyone wants to get in touch with me, that's my email address. Thank you all.
Thank you so much, Mike, for giving this presentation. I love the slogan, clean power at the heart of the energy transition. I couldn't say it better than you guys. This is absolutely lovely. And I'm happy about the solutions that you addressed, especially in terms of the high cost, which is affordability, as well as the other one is when people usually say nuclear takes longer to build, and that issue is also addressed. It would be interesting what the anti-nuclear come up with next when these have been addressed. Thank you so much. I'm gonna reshare my screen. Okay, I'm going to introduce our next speakers. The first one is David Arinze, and the second one is Joyce Mendes. Both of them are regional focal points at the SDG7 youth constituency. David is an off-grid energy expert and serves as the program officer of grid energy at Diamond Development Initiatives, DDI, where he works with the United States African Development Foundation, USAIDF, for the implementation of clean energy projects and provides technical assistance in form of fiduciary support, grants management, project monitoring, remediation support, technological support, and the facilitation of access to follow-on financing to energy entrepreneurs and business as the USAIDF implementing partner in Nigeria. My incredible colleague here, Joyce Mendes, is a techno-shamanist, I hope I'm saying this word correct, TED lecturer and social entrepreneur working on transboundary cooperation in the water energy food nexus with emphasis on energy justice. She is the Latin American and Caribbean regional focal point for the SDG7 youth constituency. Also, she's part of the youth advisory panel of the Global Center on Adoption and a member of the IRENA's Director Global Council on Enabling Youth Action, SDG7. Currently, Joyce works as a climate change consultant for UNICEF, New York, Paraguay. Joyce has co-founded several organizations and grassroots movements locally and regionally in Latin America, tackling mainly the areas of sustainability, adaptation, mitigation of climate change through education, empowerment, and research. Today, Joyce and David are going to talk about the rural electrification, solar-powered cold storage solution, solar-powered dryers, solar kiosks, milling solutions, biogas rural electrification, and clean cooking. Over to you, David and Joyce.
Warm greetings, everyone. Such a pleasure to be here. I'm David Arinze. Princess, confirm that you can hear me, and I hope you can see me.
You are loud and clear, and you look handsome.
Thank you. Fantastic. Thank you so much, Princess. It's such a pleasure to be here. I'm David Arinze. Just a little bit of addition to my introduction. I serve as the global focal point, one of the global focal points for the SDG7 Youth Constituency. And I would just leave it at that and also have Joyce introduce herself before we get right into the presentation. Joyce, over to you.
I think if you can hear us and see us well, we can go right into, because it's just 15 minutes and Princess Judy just had a great introduction. So go ahead, David, if you can see my screen.
Fantastic. I can see the screen. So we will be talking about the SDG7 Youth Constituency and a couple of our initiatives, which also cut across the interesting solutions earlier enumerated by Princess. So I will just give us that quick overview of what we do at the constituency and how we do what we do. So at the SDG7 Youth Constituency, we are the official working group for under the United Nations Major Group for Children and Youth, mandated by the UN General Assembly. We have an act, that backs our activities. So, but majorly, you can think about the SDG7 Youth Constituency as that aggregator of youths who are passionate and are working towards energy and all matters relating to energy. Additionally, we work with other organizations, who are part of the UN process, and including the IRENA, the SE for All, the Global Energy Alliance for People and for Planet. So we have quite a myriad of organizations and partners that we work with. Here they are, as shown on the screen: SE for All, the UN Energy, the UNDP, UNIDO, the HLPF, which is the UN High Level Political Forum on Sustainable Development, ECOSOC, you name it. When it comes to energy, that is where youth involvement in energy, that is what characterizes our activities at the SDG7 Youth Constituency. And two key things: how do we work? We are very big on policy. We're also very big on issues around capacity building. And so on the side of policy advocacy activities, we work with relevant partners across the globe, to ensure that youth voices are heard and youth agendas are being prioritized on the area of policy and capacity building. We have several initiatives, which in the course of the presentation, you will get to know. But one thing that we are very passionate about is we do believe that if youth are going to be at the heart of energy transition, their capacity must be built. And so we organize we're part of various workshops, various seminars, various events, global events across the globe. We have an interesting membership base of over 1,000 members, over 1,200 members, I beg your pardon, which include both individuals and also organized youth-led organizations working across energy. And this also is to showcase some of the events that we have been part of in the past, and also I'll talk about some that we have been part of this year. So last year at COP26, we were in Glasgow, where we had 2 side events, and it was phenomenal. It was amazing. It was great to see the kind of impact that it had on the youth who were present and who joined also virtually. This event held at the SDG7 Youth Pavilion in Glasgow. Also, we are at the SC for All Forum in Kigali this year, where we also had another side event, and also where officially myself and my co-GFE Asma, who took on the mandate for another 2 years, and we literally had more like a handover at the SC for All Forum. Also, we're part of the UN high level dialogue on energy, where we participated in very key and had very key strategic inputs into that engagement. We're also part of the IRENA Global Council. Currently, the IRENA Global Council is co-chaired by a member of the constituency. And also we have members of the constituency who are part of this global council that ensures that IRENA, in all of its decision processes, IRENA, the full meaning of IRENA is the International Renewable Energy Agency, and ensure that in part of its activities and engagement, youths are being prioritized and youths are not left behind. Also part of the events that I would like to talk about that have taken place this year. This year, we're also part of the Africa Climate Week, which held in Libreville, Gabon, where we had a side event focused on financing youth-led initiatives. It was such a very phenomenal session where we had panelists from like the Vice President of the Global Energy Alliance for People and Planet. We also had panelists from IRENA as well, and also the African Development Bank, as well as young entrepreneurs who are showcasing and putting in boots on the ground, working across mini-grid solutions and clean cooking solutions. At this point, I would like to invite my colleague, Joyce, who will be talking about some of our initiatives, but narrowing down to one of them, which is the Youth Sustainable Energy Hub, which is a hub that is focused on supporting youth-led projects and initiatives. But Joyce, I'll park the bus at this point and hand it over to you. Please take it over.
Thank you. Yeah. Thank you very much, David. I think it's very interesting to give as well the introduction and to situate where our work is. As well, I just want to point out that we are very open in order to have new partnerships, to develop new projects. We are constantly producing knowledge, doing a lot of capacity building, but also training the future as well energy diplomats in the different regions around the world. So I want to show you our main project, which is the Youth Sustainable Energy Hub, and it is a platform showcasing and inspiring with the work of youth entrepreneurs, practitioners in sustainable energy sector from around the world. We have different partners involved in this, which is IRENA, Sephora, UNIDO, UNDP, and UNICEF. Last year, we had 98 projects selected from around 250 applications, and also we did some webinars series. We have a report on this and mentoring and networking sessions as well. So the idea as well for this platform, what we thought is also to showcase, because sometimes they say, okay, youth, we are protesting, but we also, from the protesting to the proposal. And many of us are really, working with Let's Smile communities and in the front action for climate change, either adaptation and mitigation, because sometimes energy is not related too much to adaptation, but it is fundamental as well. So pretty much, if you check, you can, I think I'm just gonna ask you to take a look real quick here. For example, I have a look of the platform, and you can click, you can see the different names. You have the link, the website, which the type, the connections, where the city, the vision, the needs, and you can pretty much check our projects from all around the world. I invite you to do this and to get inspired, but also to support this youth. We need several projects depend on technical and financial support to continue their projects and their processes. And I just we just wanted to highlight some of them, which are related to the topic, today's topic. And we will start kind of commenting. This project, Mason project, is located in Haiti and is focused on rural electrification. It had reached more or less 114 people and is developed by University of Chile, but also an NGO called SEUS Chile. And they are in the process as well of expanding and building a solar energy center system of 7.5 kilowatt with installed capacity, with different sections of refrigeration, TV area, a community area where the community can charge their cell phones, battery bank, and even an ironing session. And this is very fundamental to highlight, because sometimes in Latin America we think, okay, we're very good in access to electricity, but whenever we see that there are some countries that are the exception, and we're working towards as well energy justice and energy access as a human right as well. Another very interesting project is this biogas community project. And this is held basically in Sabah, in Malaysia. And they're in the process of building 20 biogas units for indigenous communities in this area. They are doing it also by training youth and biogas technology. And obviously, in order to manage the food waste, the animal waste, and being able to, supply cooking as well for the community. Some of the updates, there have been 4 biogas projects already completed, 3 biogas made in a community, and 1 biogas made by the indigenous school. So it's also very interesting to see the relationship of some of the projects showcasing the platform of energy, water, and food, like this one as well, which is targeting kind of the nexus. This is developed in Kenya, and this is done by a women-led NGO. It's called Drop Access, and they are pretty much working in different solutions. The first one is a water purification system in order to actually allow 500 families to have access to drinkable water. At the same time, they are working with water pumping, a water as a meter system, and a pipe water distribution and improve infrastructure in the community. And at the same time, they are also supporting the community to have like a demo farm system, training youth and women in the best practices as well for energy, water, and food production locally. Another interesting project, well, we're gonna talk about 2 more other projects. I have so much details here, but well, this one is called Entry Community Mini Grid Program, and it's also related to rural electrification. This is a social entrepreneurship initiative developed in in Nigeria. And this energy access initiative, it is compounded by solar system mini grids, which are low cost and effective, but as well they provide different kind of service and mentorship for the communities like power system planning, operation, and mini grid design and installation. I think this is, oh yeah, we have 2 left. This is the solar EcoVad. And this project is basically allowing as well through water pump, and is developed by a social entrepreneur in Mauritania. Basically is to facilitate the irrigation on the farms, and as well they develop solar recyclable solar lamps for the community. And this irrigation is focused on the rice and on the vegetables crops in South Mauritania. But at the same time, they have very interesting systems and technologies for vaccination storage solutions. So they are also working on sustainable cooling. And this is last but not least, improved coke stoves. This is developed in Cape Coast in Ghana. In order to have clean cookstoves and avoid, well, indoor pollutions, reducing as well deforestation, but illnesses mainly in women and newborn babies. They have trained more than 30 people in how to use, and they also won the national the prize for the best improved wood stove for household challenge. So I just wanted to show you several projects and as well get you inspired that we are doing a lot of things, even from grassroots, communities, entrepreneurship, policy. So I just highlight kind of these main projects, but we have even from research and other areas of the platform. I invite you to check the platform, but I also invite you to come and support us. We need more people. We want to do as well partnerships, develop materials as well for energy literacy. I think this is fundamental to get to know all the different solutions that we need nowadays, and that we are acknowledging them as part of the solutions towards like a further and just energy transition, targeting obviously the different last mile communities. And well, we also want you to join and to get to know about our work. We have different media. We're called SDG7 Youth Constituency. We have a mailing list, and we also have a Telegram group. They are pretty much, we manage and handle a lot of information. We have done also a discussion, I believe, if I'm not wrong, maybe last year we did a discussion on nuclear energy as well, where we have different youth getting involved, commenting and showing as well the different perspectives, which is as well fundamental. We also have a newsletter where we inform obviously our work, the opportunities. Well, and pretty much I want to say muito obrigada, muchas gracias for this opportunity. And we are learning as well from the speakers. And please don't hesitate to contact us in case of any question. Thank you. I don't know if David, you want to say something as well.
Thank you so much, Joyce, for that rundown. It was amazing. Thank you so much for having us, and such a pleasure to have been able to participate here. And we look forward to the remarks and feedback going forward. All the best. Thank you.
Thank you so much, David and Jane. These are life-changing stories in their true definition. I'm so inspired right now, and I do believe that youth should be at the forefront of driving the just energy transition policies, because no one else is in a better position to decide the future than youth. And it's so amazing what you are doing, and I hope you do get more volunteers. And yeah, thank you so much. I wish you all the best, and yeah, we'll be in touch. I love your work. Can we get our speaker back? Mike, are you ready? Is Mike here?
Hey, Princess, I don't see Mike, so let me text him. In the meantime, we can move to Cody next.
All right, let me get him. Our next speaker is Cody Brimstone, who is the Chief Executive Officer of Brimstone Energy. His topic for today is turning cement carbon negative. I'm looking forward to that topic. Cody, are you ready?
I am ready. Yeah, thanks much. Let me start sharing my screen. Okay. Princess, thank you. Can you see my screen?
Yes, I can see your screen.
Perfect.
And I can hear you.
Perfect. That's even better. Yeah, so thanks very much for having me today. I'm going to talk about my company, Brimstone, which is working on a new technology to decarbonize cement. So usually start with talking about our strategy. The reason we got into this is because we want to have a global impact on greenhouse gas emissions. And we don't believe it's possible to have a global impact without involving the entire globe, right? So this can't just be a solution for high-income countries like the United States, where I'm from. It has to be a solution for everywhere. And that means it has to be affordable everywhere. Otherwise, it would be, in my view, unreasonable to expect folks from low-income countries to have to pay more for a climate solution. So we sort of say that we believe three things need to be true to decarbonize cement, but would extend this to any industry or nearly any industry. And so the first thing that needs to be true is it needs to be the exact same material. As I say, people have been building buildings with ordinary Portland cement for over 100 years. There are many regulations and industry knowledge and deployed capital around the material ordinary Portland cement. And therefore, it's both very expensive and also very risky to change to a new material. And what those things mean is it would just be very slow to change to a new material. And we don't have the luxury to be slow when it comes to talking about climate. Okay, so it has to be the same material. The second thing for cement is it has to be lower cost. This is what I touched on a minute ago. We don't believe that any process will scale quickly globally if it's not lower cost. And we all share one atmosphere, so we need to make sure that it does scale quickly and globally. And then the final thing that we believe is true is sort of obvious, but it's not so easy, which is being lower emissions and being obviously even zero carbon, right? If you're not zero carbon, we're not solving the problem. And importantly, we need to be zero carbon even in the context of what we call the least cost operation scenario. So this hits back on cost. So there are any industrial process, there are lots of ways to operate that industrial process. You can choose from a variety of fuels, from coal to hydrogen to electricity, and you could put that in lots of locations. But industries tend to want to make the most money, and therefore they use the cheapest way to do things. And in many places of the world, fossil fuels, especially coal, is the cheapest form of energy. And I mean that as in directly producing heat from those fossil fuels, right? It's more expensive to make electricity. That's a different story.
I'm sorry to disturb you. I don't know if you are moving your slides, but they are not moving.
I have not yet. Yeah, thank you, Princess. I've not yet moved my slide. I'm just
all right. It's
fine.
I
appreciate it. Yeah, thank you. So the final thing is, under the context of a least cost emission scenario, or sorry, a least cost operation scenario, which in many places still uses a fossil fuel and likely will for some time, still has to be zero carbon, because it has to meet that criteria of being both lower cost and zero carbon. So just to summarize, lower cost, zero emissions, and the exact same material, and that's what we're building. Okay, so Princess, can you see my next slide?
Yes, I can see it.
Great. Perfect, thank you. Okay, so to give a little background on cement industry in general. So cement, it's about $1 trillion global market. It's responsible for 5.5% of greenhouse gas emissions. It's about the same as cars. Cars are 6.5% of greenhouse gas emissions. You've probably also seen, or you may have seen, numbers like 7.5 or 8% of CO2 emissions. That number's the same. This is just a statement of greenhouse gas emissions are not all of CO2 emissions. Or excuse me, the other way around. CO2 emissions are not all of greenhouse gas emissions. All right. With increasing urbanization and development, it is widely expected that consumption of cement is expected to increase, and especially in rapidly developing economies, which is again why it's so important that any solution to truly decarbonize cement is a lower cost solution, because it needs to be affordable. People deserve to live in with a high quality of life in modern buildings. Okay, so cement, so also just to break down the market segments a little bit. So cement, as we talked about, is really just the binder. So it's not the building material, it's the sticky stuff that sticks gravel together. Once you mix cement with sand and gravel, you make concrete, which is the building material. So that would be the mixture of Portland cement, which is the middle bar on the bottom right, mixed with aggregate, which is gravel. You form concrete. There are also other materials like supplementary cementitious materials, which are included here. And then related in cement, there's also carbon capture and sequestration, because the material cement itself naturally will sequester some CO2. Okay, so this is a background of how cement is made today. In the conventional process to make cement, you start with a rock like limestone, or you start with limestone. And the reason you start with limestone is because you want to access the calcium. Cement is a calcium-based material, so you need some source of calcium. And the way that we access this calcium is we heat the limestone up. When you heat the limestone up, this chemical reaction happens in red. So limestone with heat reacts to form calcium oxide plus CO2. So the rock itself, which contains CO2, releases that CO2, leaving behind the calcium fraction. And this chemical reaction here is why people say that cement is particularly difficult to decarbonize. That's because most of the CO2 emissions, 60% of the CO2 emissions, have nothing to do with burning a fossil fuel. They all come from the rock. All right, and then the remainder of the CO2 emissions associated with cement do come from burning a fossil fuel. In order to reach the temperatures required to do this chemical reaction. Okay. So once the cement is produced, you then need to mix it with something called a supplementary cementitious material. This is where the story gets a little bit more interesting. So a supplementary cementitious material is a source of amorphous silica. And where it comes from today is the ash from a coal-fired power plant or the ash from a steel mill. That's fly ash and slag, respectively. And those two products historically have been very abundant, but with global energy transition, where we make less of our electricity from coal and we make less of our steel from coal as well, we do more recycling. These materials that are additive to the cement industry are becoming scarce and therefore expensive. What that means is that the cement industry really has two problems. They have one problem, which is the CO2 problem, which is there's a lot of CO2 associated with the industry, and it's both from a fossil fuel and from the rock. And they have a second problem, which they depended on this waste product from the fossil industry, and that industry has been transitioning away from coal for a long time. And meanwhile, cement production and consumption have been increasing for a long time. And we've reached a point where supplementary cementitious materials are scarce. Okay, so once you have that blended product, you can then mix it with sand, gravel, and water and create concrete. That's of course, the building material. Okay, so my company, Brimstone, we have developed a new process in order to produce this material. So we start with a rock that is not limestone. We start with a calcium silicate rock. So the common version of this rock that people have heard of is called basalt, but there are hundreds of other rocks. And in fact, these calcium silicate rocks, they make up about 50% of the rocks in the Earth's crust, so they're incredibly abundant. And the important thing is these rocks contain calcium, but they do not contain CO2. So unlike limestone, when we extract the calcium from these rocks, no CO2 is released. This automatically eliminates 60% of the CO2 emissions. The second thing that happens is the silicate fraction of these rocks comes out of our process chemically and physically identical to something like fly ash. So it passes, just like our Portland cement passes the existing Portland cement standards, so does our fly ash. So we make both the Portland cement component and the supplementary cementitious material component using this process, which means that it's a huge market simplification. No longer would the industry have to source this SCM from a faraway coal-fired power plant, which is becoming scarce. Instead, it can make both the products at a single plant. And this is the way that our process can lead to a lower cost product, because we can make both Portland cement and the SCM. And then we can take these materials and mix them together in the exact same way, no difference whatsoever, add sand and gravel and water, and we can make concrete. So there's just no difference whatsoever with our process. This is just a new process to make the exact same material. The final interesting part of our process is that these calcium silicate rocks, they also contain magnesium. And our process removes that magnesium in a reactive form. So just sitting in air will react with CO2 in the air, forming magnesium carbonate, which is permanently stored CO2. So when we take that into account and look at the emissions intensity of this process, you can see that it's quite good. So here's kilograms of CO2 per ton of cement on the y-axis. Here's the conventionally produced cement on the left and Brimstone produced cement on the right. Using a global average fuel mix, it releases about 700 kilograms of CO2 per ton of cement via the conventional process, and a global average fuel mix is a mixture of coal and garbage. So it's a mixture of coal and garbage. Emissions, if you use pure coal, would go up a bit, and if you use clean energy, would go down, but in a conventional process would not go down to zero, again, because we have that CO2 associated with the rock. For our process, using a conventional global average fuel mix, that's a mixture of coal and garbage, we would still have a negative 131 kilograms of CO2 per ton. If we use clean energy, we get down to minus 500. And if we were to actively drive for sequestration with our magnesium, we could get down to negative 1,000 kilograms of CO2 per ton. If for some reason we were to use pure coal, then our emissions would be around positive 100 kilograms of CO2 per ton. But as I mentioned before, cement actually passively absorbs CO2 over the course of its life. So the lifetime emissions of this product would still typically be carbon negative, meaning that regardless of the fuel source, we're ultimately producing a carbon negative product, meaning we don't have to wait for new technologies to come online. We don't have to wait for and combine and multiply risk. We can start deploying now, and that's in fact exactly what we're doing. We are building our first pilot plant in the United States as we speak. Okay, so the first thing people always ask is, where's our rock? And you know, since there's not a chance for questions here, I thought I'd just answer that. So this rock, as I mentioned, is about 50% of the rocks on the Earth's surface, is about the most abundant rock there is. So this rock is truly everywhere. This rock is also not looked for because no one uses it today. But these are the known deposits. You know, even though people are not looking for it, these are still the known deposits. And there are many, many more deposits than this that we've found. This rock is much more common than limestone, which is the current rock that's used today. Okay, so in brief summary, what our process can do with cement is it eliminates process emissions from the production of ordinary Portland cement. It vertically integrates the production of Portland cement and supplemental cementitious materials. This leads to cost parity or better, and it's carbon negative regardless of the fuel, but we also have a pathway to sequestering up to 1 ton of CO2 per ton of cement, meaning that we could be a carbon solution instead of a carbon problem. And the U.S. State Department will be sending a mortar cube, so a cube of mortar, that's sand and cement, made with our carbon negative cement. It'll be the first ever carbon negative mortar cube ever produced. And that'll be in the blue zone at COP27. So I look forward to seeing some of y'all there, and you can come say hi and check out our mortar cube. And I really appreciate the opportunity. Thanks so much.
Thank you so much, Cody. You know, after your presentation, I have hope that we will reach net zero by 2050. And I volunteer to gather all those rocks for you here in South Africa. So yes, ladies and gentlemen, we've come to an end of our session for today. Thank you so much for attending, and a big thank you to our speakers for sharing their knowledge and expertise. And I'm sure I speak for all of us when I say we learned a lot. I'd like to invite you all to our next event, which is happening on the 2nd of November, where we will be focusing on climate action. How do we implement climate solutions in developed and non-developed countries? Those questions will be answered in our next event. So please stay tuned for registration links, which will be provided by Nuclear for Climate. And also, I'd like to invite you to follow Nuclear for Climate on social media platforms. We are on Twitter, we are on Facebook, we are also on LinkedIn. And please do check our website also for more information on activities and everything that will be happening at COP. Thank you once again, and I do wish you all a great day ahead.